Alright, welcome to today's edition of Electronic Circuits. Today I'm going to show you about the solar circuit, which we use as a solar power supply. It's a regulated solar power supply. We have the solar panel here, we have the battery, we have the circuit here that is controlling the charge of the battery, and it's also controlling your load. This solar system, solar panel itself, is very amazing in such a way that on the solar panel itself we can generate volts, which is useful for our daily day activities. Now let's check what is the output. See, you have to position this to the sun. That's why we have to bend it. Now see the output. Here we have. All right. See, 18.52 from the solar panel itself in the sun. This is very useful for us in if you have a low voltage appliances that we want to power. We can use this to charge up our battery anytime that we want to use it. Whenever there is sun, you charge up, and then maybe at night you use your battery for your load. So how does this thing work? Okay, the solar energy, this solar panel receives power from the solar energy and it converts it to electrical energy, which I showed you now. Here you have the 18 volts 0.5 maximum output. Okay, so this output, this voltage from the solar panel is going into a charge controller, which will use this regulator, which is called LM2941CT regulator. So regulate is an adjustable regulator, which I set the output to 13.5 volts in order to charge our battery. 13.5 volts is required for the battery so that it will not be overcharged. When the voltage across the battery is up to like around 13.5, then before then it will slow down so it will protect your battery from damaging. Okay, from this now, what we have again from this circuit, after this stage it moves down to activate a transistor here. The transistor, it has a resistor to which controls the base current going to the transistor. So the transistor is also used to activate this relay and thereby keep the output. I have two things there. I have the switch here which controls the load output, and we also have the fuse here which is used between the solar and the battery so to prevent high current from flowing and damaging the battery or the panel or the system. So now let's see how it works. Before we go to how it works, I would like to show you the charge on the battery itself. This is your battery. You have here, see, you have 11.75 volts on the battery. So now let's go. Okay, plug into the circuit. Now it's charging. How do you know that it's charging? Okay, let's try to check. I have this from the battery and I have this. If you wait for a while, this will start to flow. See, from 11.75 it moves to 11.76. It has slowed down so that the current will not really affect the battery. So it will just see trying to go to 11.7. So that's how it goes gradually. The rate is very slow because this amount of charge is going up to the battery voltage. So it has to slow down. Now, this circuit, which we call a regulated power supply, solar regulated power supply, it has two outputs. The first one, that we have the fixed output and we have the variable output. The fixed output, we made it for lower currents, so it is being divided into three. Maybe you have 3 volts, you want to use 3 volts, you want to use 6 volts, you want to use 9 volts. We have the options here, so you can use this for any low voltage, low current circuit which require the 3 volts, 6 volts and 9 volts. So just like example, you have your LED lights, you want to light up, you can use it. Now let's see the output that you want. From the end of this Zener diode, you have 3 volts flowing from this circuit. Alright, so sorry for the break. Now I want to show you the outputs that we have here from the fixed circuit. Now the output from the fixed one here, you have the first one which is 3 volts here. The second one we have is 6 volts. You see it here, 6 volt output, a fixed 6 volt output. No matter what happens, your battery level anything, it is turned up to 6 volts. You have the last one which is 9 volts here. So they are fixed output which you can use for some of your appliances that require very low current and this. Now the major one is the variable output, which is being done by the help of this regulator LM317. Is a variable regulator which has like around 0, which can operate on 0 to 37 volts. So this variable regulator is used for our variable output. Here, because with this potentiometer, you can regulate how, and how the output will be. What value do you want for your output? Let's try something here now. From this place, I have this network for my variable output. You see, you have 9 volts as the output. Now, if you like, you can put your output to be less than that or more than that. You can change the output and it will regulate down to any value. You have 1 here, you have 3, 5, 7, 8, 9. See, you can vary it up to any level you want. But let's say we need a 9 output here now to operate any load. For example, I have with me here a simple motor, DC motor, which is using 9 volts. You can operate this with this 9 volts. It works perfectly. So how do you test that? Let me show you and you see how it works. Okay, you can see now 9 volts. If I hold this switch, then it will be off. If I on the switch, it should be on.